Okay, here we have a lovely question all about resistor networks. This is an SL question from the B5 topic, so feel free to hit pause, try the question, and then see the explanation. Okay, as ever, I'm going to go into probably far too much depth here. I'm going to show you a full worked out solution. However, obviously in an exam situation, you probably have to think of some tricks to get there. Let's see if we can work that out once we've seen the solution. So we've got these three complex networks. They are all combinations of series and parallel resistances, and what you're trying to do is work out which one has the lowest resistance and which one has the highest resistance, and then go in order. So let's start with the top one, P. Now you'll notice here P is made up of two series in resistors, R and R. And then we have this bit here. Now this is a parallel combination, and you should know that if you are combining things in parallel, that if we name this section A, this is R, A, resistance of A is 1 over R plus 1 over R, which is 2 over R. We're then going to flip those, and we're going to get R over 2. So our total resistance of P is going to be this resistance, R plus R over 2, that's the resistance of RA. We're going to get 5R over 2. Okay, so I think if we're thinking about tactics here, I would immediately be looking at this resistance of P being probably my highest resistance, because we have two resistors in series there. Okay, so immediately what I'd be tempted to go for is answer D. It's the only one that has got P at the end. Okay, just to be clear here, we have two resistors, so we're going to have a minimum resistance of 2R here, and then we're going to have R and R here. And really these R's in the series are going to be the bits that are adding up the resistance. Let's check if I'm right or not. Maybe I've made a mistake. I'm quite happy to admit it if I have. So for Q, we have got another section B. Well, that is just three resistors. So we're going to do 1 plus R plus 1 plus R plus 1 plus R. That's 3 over R, and we've got R over 3 here. Okay, so we're going to add that to our single resistor, R. We're going to get something pretty ugly, 4R over 3. Okay, so I'm right there that RP has got a higher resistance than RQ. Okay, and that kind of makes sense. Again, D is the only option where P is going to be after Q, so I'm pretty confident now D. Let's just check this one here now. We're just going to rule out a couple of answers here. Okay, let's just check on R. Now R is a tricky one because we've got one series resistor, we've got two here connected in parallel with one. Ooh, that's RC. I'm going to call do it this way. I've got RC, 1 over RC is this 1 over R, that's on the top branch, plus 1 over 2R, which is the branch on the bottom there, which is going to give me 2R over 3. Okay, we're just going to remember to invert that, and then I'm going to remember to add RR, which is R plus 2R's over 3. I'm very bored of the letter R now, and hopefully now you can see. There we go. We've got a 5R over 2, a 5R over 3, and a 4R over 3. All right, which means that D is the answer. Now, as I've alluded to during that, you don't have to do the full working out. Okay, there's lots of little tricks that you can be identifying here. Like I said, the first thing I did there was notice that in this circuit we've got two resistors, and this circuit we've got one, and therefore, due to the laws of combining resistances, going through that process isn't necessary. I think you would go through this whole process if you have time, and also if you're maybe unsure. Okay, maybe there's a less obvious answer there. For me, I found that one fairly obvious straight off. However, perhaps you might have two resistors with two combinations where we have a series one here, and that would be the interesting bit for me. Okay, as ever, please let me know if you've got any questions.